Okay, I want you to imagine something for a second. A database so big that it spans the entire planet. Not just a bunch of copies in different places, but one single, unified, consistent database that operates on a global scale. That's exactly what Google set out to build with Spanner, a system that had to solve one of the most fundamental problems in all of computer science.
So how do you even begin to build something like that? The question isn't just about making it big, right? The real trick is consistency. How do you make absolutely certain that a transaction happening in a data center in Europe is perfectly, and I mean perfectly, in sync with another one happening in North America just nanoseconds later? This was the monumental challenge Google took on.
And in this explainer, we're going to break down exactly how they pulled it off. We'll start with the huge data problem they were up against. Then we'll introduce their radical solution, Spanner. We'll uncover its secret ingredient, this thing called TrueTime, see the incredible features that it unlocks, and finally, we'll look at how it powers one of the biggest businesses on the planet.
All right, so to really appreciate what a big deal Spanner was, you gotta understand the impossible choice that Google's engineers were facing at the time. With their existing systems, they were stuck between a rock and a hard place.
You see, on one hand, they had Bigtable. It was ridiculously fast and it could scale out to handle enormous amounts of data, but it had what's called weak data consistency. In simple terms, you couldn't be 100% sure you were seeing the very latest version of the data across the globe. Not great. Then on the other hand, you had Megastore. It gave you that strong consistency. Every read was guaranteed to be the right read, but the trade-off? It was slow, painfully slow. So you had to choose. Do you want it fast or do you want it right? For Google's most important apps, neither one of those was good enough.
So what did Google do? They said, forget that choice. We're not going to compromise. And they built Spanner, a database designed from the ground up to be both globally scalable and strongly consistent, the best of both worlds.
Spanner is a completely different beast. It acts like one single database, even though it's spread out over millions of machines worldwide. Every little piece of data has multiple versions and gets replicated in real time. But here's the real magic. It guarantees something called external consistency. Now that sounds super technical, but all it means is this. If transaction A finishes before transaction B even starts, the database will always see it that way. No exceptions. Sounds simple, right? But doing that across the whole planet, that's the holy grail of distributed systems.
So how do they pull this off? Well, they call the whole system a universe, which is pretty cool. And that universe is split up into zones. You can just think of a zone as a data center. Each one has its own army of servers, but they all work together as one single cohesive database.
And if we zoom in even more, the data itself is stored in these little chunks called tablets. Now, the real challenge is making sure every single copy of a tablet is exactly the same, everywhere, at all times. To do that, Spanner uses this really clever system where all the copies basically have to vote and agree on what the official data is before any change gets locked in. It's like achieving democracy at the speed of light.
Okay, so how on earth does Spanner get that perfect ordering of transactions across the globe? This is where things get really, really clever. The secret wasn't just about managing data. It was about mastering time itself.
The key to everything is an API they built called TrueTime, and the idea behind it is it's a total shift in how we think about time. See, instead of asking a computer, hey, what time is it, and getting one specific number back, TrueTime basically admits, look, I can't tell you the exact time, but I can promise you with 100% certainty that it's somewhere inside this tiny, tiny window.
Think about it like this. Your computer clock might say it's 10 a.m., period. But TrueTime, it would say something like, okay, I guarantee the real, actual, universal time is somewhere between 9:59 and 59.998 seconds and 10 a.m. and 0.002 seconds. It's not just giving you the time, it's telling you its own margin of error. And that little bit of honesty changes everything.
And how does it get this incredible precision? Well, it's pretty wild. They use a mix of GPS receivers and actual atomic clocks in their data centers. Servers are constantly checking in with these time masters to stay in sync. Then the system does the math. It calculates its own uncertainty based on things like how long it takes for the signal to travel or just the natural tiny drift of computer clocks, and that's how it spits out that guaranteed time interval from this time to that time.
So once you can actually trust time, like really trust it, Spanner can suddenly do things that were just considered impossible for a database this big. It just unlocks a whole new level of features.
So what does that actually mean for developers? Well, you get that external consistency we keep talking about. You can look at data from a specific point in the past, and it's perfectly consistent across the whole world. And maybe the most amazing one, you can do read-only transactions without any locks. That means you can run huge, complex reports on your live data without ever slowing down the system. It's a huge deal.
And here's why that matters so much in practice. A standard transaction, one that reads and writes data, still needs to lock stuff for a split second. That's normal. But look at the other two, read-only transactions and snapshot reads. They are completely lock-free. Because Spanner knows exactly when the read is happening thanks to TrueTime, it doesn't have to get in the way of live operations. That's a massive, massive performance boost.
Okay, this all sounds amazing in a white paper, but does it work in the real world? Oh yeah. Let's talk about F1. And no, not the race cars. We're talking about the database that runs Google's entire advertising business. This is where Spanner really had to prove itself.
So before Spanner came along, the F1 database was this massive, sprawling thing that had to be manually reshuffled as it grew. Just think about that. As the business got bigger, engineers had to go in and, by hand, reorganize this mission-critical database. The last time they had to do it, it took more than 2 years. 2 years of incredibly risky, stressful work.
So yeah, migrating to Spanner was a no-brainer. That 2-year nightmare of reorganizing the database? Poof, gone. Spanner just handles it. What if a whole data center goes offline? Spanner just fails over automatically, no sweat. And most importantly, it gave them those rock-solid transactional guarantees they desperately needed to run the business.
And the scale here, it's just hard to wrap your head around. On any given day, the F1 system on Spanner is handling over 21.5 billion read operations. So no, this isn't some side project. This is the engine of a multi-billion-dollar business.
And this all comes back to this one beautiful line from the original research paper that just nails it. It says that as the system gets better at measuring time, as that little window of uncertainty gets smaller and smaller, the cost of providing these super strong guarantees goes down. In other words, better clocks literally make a better database.
So this leaves us with a really fascinating thought to end on. Spanner used a trustworthy sense of time to solve a global database problem. But what else becomes possible when you can fundamentally trust the order of events across a giant distributed system? What other impossible problems are now on the table, just waiting to be solved?